Probability distributions describe how values are spread out in a data set. Understanding them is essential for Monte Carlo simulation, statistical modeling, and real-world applications. Let's explore 4 of the most commonly used probability distributions. Uniform distribution, normal distribution, binomial distribution, Poisson distribution. Each of these distributions has unique properties and applications. 1 uniform distribution. The uniform distribution is the simplest type of probability distribution. In a uniform distribution, every value in a given range is equally likely to occur. Example, if you roll a fair 6-sided die, each number from 1 to 6 has an equal probability of appearing. This is an example of a discrete uniform distribution. In contrast, a continuous uniform distribution is used when values can take any number within a range, such as generating random numbers between 0 and 1 in simulations. 2. Normal distribution. The normal distribution, also known as the bell curve, is one of the most important probability distributions. It appears in many natural and real-world phenomena, such as heights and weights of people, test scores, financial market returns. In a normal distribution, most values are clustered around the average, mean, with fewer values at the extremes. The shape of the curve is symmetric, meaning values on either side of the mean are equally likely. The normal distribution is widely used in statistical analysis, hypothesis testing, and Monte Carlo simulations. 3. Binomial distribution. The binomial distribution models the number of successes in a fixed number of trials when each trial has only 2 possible outcomes, success or failure. Example, if you flip a coin 10 times, the binomial distribution can predict how often you'll get heads. Key properties of the binomial distribution. The number of trials is fixed. Each trial is independent. The probability of success remains the same in each trial. The binomial distribution is widely used in fields like medicine, testing the success rate of a treatment, and quality control, checking if a batch of products has defects. 4. Poisson distribution. The Poisson distribution is used for counting the number of events that occur in a fixed period of time or space when the events happen independently. Example, the number of customers arriving at a store per hour, the number of emails received in a day, the number of defects in a manufacturing process. One of the key properties of the Poisson distribution is that rare events are more common than extreme events. It is widely used in queuing theory, risk analysis, and network traffic modeling. Which distribution to use? Use the uniform distribution when all outcomes are equally likely. Use the normal distribution for natural data that clusters around a mean. Use the binomial distribution when there are repeated independent trials with 2 possible outcomes. Use the Poisson distribution when counting events over time or space. Conclusion. Understanding probability distributions helps us make better predictions in simulations. Monte Carlo methods use these distributions to model uncertainty in finance, science, and engineering.